welcome and thank you for coming to this session to ask us all about 802.11ax. And for those of you that don't know me, Jamie Fink, I was the co-founder of Mimosa and CTO for the Fixed Wireless Group. So I'm still kicking it and working on all of the fixed wireless gear for Airspan and Mimosa now.
Okay, guys, just a little quick background on Mimosa. Jamie and another colleague of his, Brian Hemming, was the founder of Mimosa. And Mimosa got acquired by Airspan in about 2019. Although Airspan is based in Boca Raton, Florida, we actually have a location, Mimosa location in Santa Clara, California. And Jamie has the slide here up for the 6 series. He can run through a little bit about it, but obviously if you guys have already been to WISPAPALOOZA, been at our launch party, or read any of the press releases that we've had so far, you probably already know about the Wi-Fi 6 solutions that we will have available. So if you have any questions, feel free to type it in the chat, or feel free to ask the question live as well.
Yeah, and I'm happy to give a very brief kind of re-intro to what we announced at WISPAPALOOZA. Pretty game-changing next-gen access point in CPE, the A6 and the C6X that we'll just call the 6 series here. But certainly, I hope most of you, to Ashley's point, have had a chance to go check out the specs. But today's really meant for being able to ask some questions. So I don't want to take up too much of your time doing a dog and pony show, but also to be able to ask the questions. So I'll just go through about 5 minutes maybe of reintroducing the product, and then we can get into your questions. So as you can see, the first instantiation of the product that we're introducing is a sector. So this is a 90-degree sector. And this is all based on the new 802.11ax standard. So the Wi-Fi 6E and the new 6 gigahertz, which is in the process of getting opened up with the FCC. And I know we're gonna have a lot of questions about FCC certifications. So we'll deal with that in the questions so that we can answer specific questions of those. We got somebody that's on mute. That needs to go on mute there.
I'll mute all for now, and that way, if anyone has questions, feel free to use the reaction button at the bottom and just raise your hand, right?
Thank you. Getting feedback. And I'm unmuting myself. Okay, great. So just brief introduction to the specs of the product. Using my mouse here. So as I mentioned, this is a sector product. So 90 degrees, first version. This is an 8x8 implementation in the antenna. So this is a beamforming solution, which is great for a lot of reasons. It gives us extremely high antenna gain on the access point, and I'll talk through why that's so important in a few minutes. But beamforming also, as many of you know, gives us more kind of pencil thin beams towards customers, and that helps us reduce radiation. The beamforming is also kind of a necessity, of course, as we do multi-user MIMO. So when I'm wanting to have multiple clients receive signals at the same time, multi-user MIMO in the downstream direction, we do that using beamforming technology. So this is a very different technology and antenna than what we've introduced in the A5 product line. So this is all new technology. The other key aspect, of course, of 802.11ax is OFDMA. And we can jump in more detail on each of these topics, and I'll avoid doing that for now. But broadly speaking, OFDMA gives us multiple users being able to talk to the access point in the upstream direction at the same time. And unlike multi-user MIMO uses spatial diversity with beamforming to talk to 4 different clients simultaneously. In OFDMA, instead, we're actually going to allocate a portion of the channel. So for example, if we're running on a 160 megahertz channel, in the new wide open 6 gigahertz band, we would split up the channel to 40 megahertz per each user upstream, and we schedule those users to simultaneously transmit. So OFDMA is huge in getting us to much higher client counts. We've already tested north of 250 clients to this base station, to the A6, which is great. So it's a huge improvement in just ability to connect those clients, but also in the latency. OFDMA, because we can have multiple users transmitting simultaneously, our latency is a fraction of what it used to be in the old A5 and TDMA world. So big changes here. The big headlines here, though, are really the speeds. 7 gigabits per second on the access point. So that's the downstream maximum capacity. So we would split that up into 4 users, and that translates into about 1.75 gigabits of maximum capacity to each user in 160 megahertz channels. And from a spectral efficiency perspective, it's by far the highest spectral efficiency product out there now. So this is now a 60 bits per hertz on a single base station. The previous record, I think, was 20 bits per hertz, so it triples that. And then when we do GPS sync, as we release that software, that's going to take us to 120 bits per second per hertz spectral efficiency on a back-to-back configuration when we're hosting multiple of these at power. So these are the broad key specs. I'll get a little bit into some of the additional specs here, just so you guys can see them kind of in a spec sheet format. Antenna gain is pretty incredible here as well. This is actually quite a compact access point. So if you're looking at kind of my size here, I'll step back a little bit so you can see it. It's about this high, it's quite small, and it's about yay wide. And I'll show you some comparisons as to what that is. But why is that important? Obviously, the cost, if you're doing tower rentals on linear footage, is number one, as well as wind loading on the access point. But also antenna gain is incredible here. As I was mentioning, it's 8x8. So we have a lot of processed MIMO gain, as we call it. So we're picking up about 6 dB of gain by doing beamforming on this product. So this is a 24 dBi aggregate gain, which is incredibly important because as we move into the 6 gigahertz especially, we're dealing with much lower EIRP levels for the CPE. CPE will be only allowed to do 30 dBm, so we're dealing with shorter distances in the 6 gig. And to make some of that up, that asymmetry between the access point and the CPE, the access point's 36, the CPE is 30. So we want to make that up with as much antenna gain as possible on the receive side of the A6. So this is pretty much unparalleled in its antenna gain and the size that we're achieving here. So just to show you some comparisons of sizes out there. So it's about 19 inches by 11.5 inches, as I was showing. And if you compare that to the other products that are sectors like this in the industry, a couple things here. First and foremost, we've optimized the antenna across the whole band. So one product, all the bands, which is great. So we're able to have one solution. You don't have to stock multiple versions of product. Makes our lives a lot easier to deploy and not have to worry about which one I might put in for 5 gigahertz or versus 6 gigahertz. Then as we look at like the other massive MIMO solutions out there, there's competitive 14 by 14 products, and you can see we're less than a third of the size, but 10 dBi more in gain than the best integrated beamforming sector out there. So I think it's pretty incredible what we've packed in from a performance perspective. We are also the only folks out there with a standard power 6 gigahertz solution. So we have up to, I think, 29 dBm of output power. So again, we've really made sure that we could have all the features we want for 5 gig and 6 gig in one platform. That's going to make our lives a lot easier. The last thing I'm going to touch on before we start heading into questions is just some of the specs on connectors. Lots of changes here as well, and lots of new things for us. We're introducing 48 volt for the first time. We are maintaining a PoE and providing a gigabit PoE plus interface that's active and passive. And we also are introducing 2 SFP plus connectors. The reason we decided to do this was we heard a lot of feedback that as we move towards fiber interfaces, that's going to raise a lot of cost of putting in 10 gigabit grade Ethernet switches, fiber switches at tower locations or at sites. And a lot of the sites are smaller and really can't afford to do an outdoor switch. So we felt that it was a really great balance for us to introduce 2 SFP pluses so we could daisy chain. So I can bring in a connection to one radio and daisy chain to the next. And so I can bring in at a small site a backhaul and bring it directly into the access point, and then we can daisy chain to the next access point and to the next access point, et cetera. So we can go switchless at smaller sites, which I think is a really great feature. It's going to help keep costs down as these performances continue to go up, up, and up. And again, last thing I'll touch on is the CPE, and then we'll have plenty of time to run into questions here. So most of you are familiar with our X series antennas. Those are the twist-on antennas that we internally designed, very cost-effective and have incredibly high isolation. We're really proud of the design we've done there for both cost and performance. But the cool thing with the C6X is that if you understood the C5X really well, you'll understand the C6X. It really just mirrors the features of the access point. So 1024 QAM, 160 megahertz channel support. This is a gigabit PoE plus. So because it's 1.75 gigs of maximum capacity, we can get 2 gigabits of performance on the gigabit Ethernet port. So we wanted to keep it at an affordable price. I think we've done a great job of introducing extremely high performance on the client, but at a really affordable price for such a high performance solution. And of course, it supports OFDMA and all the things that we need to get this great new performance out of the 11AX base station, the A6. So this takes all of the current antennas. So just any antenna that we've done for the C5X works on the C6X, super easy. So you can swap in the 25, the 20, the 16, or the 12 dBi that we're showing here on the slide. And also great news, we are going to be introducing, to start with, a 30 dBi in early of next year, and then we're going to go even bigger than that later off in the year. But the good news is we will be introducing high gain antennas for the entire X series of products, which I think is great for everybody. So with that, I don't want to take up too much time on presentation stuff. So I'm going to pause here, and we can start to get into some of the questions that I think are starting to queue up. So Ashley, if you want to, I'll take a minute to read through some of these questions. If you guys have anything that you want to take a pause on while I can see what we're dealing with on questions so far.
Sure, absolutely. And just so you guys know, we will have a Kahoot game, which is kind of like a trivia game after this session. A couple of questions that might come up is like, where are we headquartered? What's the A in our model stand for, and those such things. But based on just what Jamie had already gone through, you can already guess the A stands for access point. But there are some other ones that you'll see that'll come up in the Kahoot game. And it'll be 20 seconds per question that you'll have the opportunity to answer it correctly, and whoever answer it quickly and correctly, that person will win an AX surprise gift at the end of the session that we'll mail to you. So I just want to throw that out there. Pay attention to some of the conversations that might be going on during this session, because the questions might be in the Kahoot game. And I will share with you the Kahoot link and the pin. That way you can get on either on your desktop or via your mobile phone. It's very easy. You don't have to download anything. It's just a web browser with a pin. I do ask that when you do enter your nickname is to put your first name and the company that you're with. That way we can get in touch with you after the session if you are the winner. Thank you.
Great, thank you. So I've caught up a little bit on some of the questions here, so I'll try to answer them, and I'll read them off for everybody here, of course. So the first question is really on kind of next versions of products that are coming. Will this lead to additional point-to-point products with even higher capacity? Will there be a 7 gigabit access or a point-to-point link? So the maximum we can do in point-to-point with the chip technology is 3.5 gigabits. We actually have already done a demonstration of this and did a press release about this last year. but it was early on in the process. So yes, absolutely, you can expect point-to-point products coming in the earlier part of next year that'll handle dual 160 megahertz channels. Now, that's a lot of spectrum, so you absolutely are going to need to be up in the 6 gigahertz to do that. And in the 6 gigahertz, you must be running with GPS location in order to provide that information to the FCC to be able to look up channel coordination and interference. So there will be versions of products with GPS coming out that support even higher capacity, so up to 3.5 gigabit. I can't tell you too much more detail at this point, but yes, absolutely, the point-to-point lineup will ensue. The one point about point-to-point as it relates to the C6X, in the past, we have done we allowed the C5X to work in point-to-point or the point-to-point or point-to-multipoint mode out of the box. We are not doing that with the C6X for a number of reasons. There is a license key that's required, so it's an additional fee to be able to do point-to-point with the C6X. But before we get too deep into that, the reality is that the C6X without having GPS in it is not allowed to be used in the 6 gigahertz band by the FCC. So the C6X is really designed to talk to the access point. The access point has GPS and it will get the coordination from the FCC AFC system. So that said, it's really not terribly exciting for the C6X for point-to-point in the upper band because it doesn't run GPS. And we did that for cost reasons. We need to keep the CPE as low cost as possible, of course. So, there's not terribly too much benefit in the 5 gigahertz because it's going to be just, very difficult to come by 160 megahertz channels, as you probably know. So there's not too much different in point-to-point multipoint mode other than 256 QAM versus 1024 QAM on the C5X and the C6X when it comes to a single channel, 2-stream point-to-point. Hopefully that answers that question, but a lot more coming in that scenario. Okay, so I answered around the license keys. There are no additional license keys, so it comes out of the box point-to-multipoint, and that is full speed at that license. No license key required. So it's only the point-to-point license key that applies. There was some question around different bands. So I'll take some Canada questions here. So the question was that obviously you need to use DFS in Canada as we do in the US. And they'll be limited in some cases to 10, 20, 30 megahertz wide channels without noise. What kind of capacity would we see in those bandwidths? Well, it is pretty simple. It is a strict divide through. So if you divide the numbers that are based on 160 megahertz, so a 160 megahertz channel, if you go to a 40 megahertz channel, it is literally just 25%. So you can do the math on those things. But as far as what channel sizes we support, it is still 20, 40, 80, or 160. So we cannot carve up the base channel sizes. There are some differences here, though, in the way that things behave. So there may be opportunities where you have a little bit of noise in a portion of the channel and you want to use a wider channel. Well, that's where OFDMA can be useful. When it's possible for us to break apart the OFDMA symbols into smaller resource units and null out resource units that are having problems with interference. So that may let us run on operating channels that are larger, even if there might be some noise in the middle. So there's going to be a lot of cases where you're going to get more usability of the spectrum because of all of the technology in 11AX. The noise mitigation factor is so much better on this product than any other generation of products that have been available in the market because of OFDMA and these resource units, as well as the beamforming technology. But to be specific, we can't set, say, a 15 megahertz channel or a 25 megahertz channel. We still need to step to 20s, 40s, and 80s. And then we can hopefully leverage the OFDMA to ignore portions of a channel that may have some problems. Maybe there's a 10 megahertz chunk with an issue. That would be ideal to be able to take advantage of those resource units. OFDMA basically goes from previously, the operating channel was the entire channel with 802.11ac. With OFDMA, the resource units are split up into 2 megahertz chunks. So there's literally a whole series of radios at the digital level that can now be activated or deactivated automatically by the product. So it's a completely different technology where we used to take noise in one part of the band, and that would impact the entire channel that's operating. So it's a very different situation with noise mitigation and channel selection as a result of that. There was a question also around channel sizes. I mentioned the 200 client count, and what are realistic speeds, and would we be able to do 200 clients at 100 megabits? Well, I guess first and foremost, it really depends on what your guaranteed bandwidth needs to look like at peak. So very clearly, we can hit those speeds no problem in speed tests, but if you're saturated at peak hour, obviously we're going to be lower than that by just doing the simple math, because 200 times 100 is way more than is capable at that point. So we need to take into account what you want your peak hours to be. But the practicality of, I think that we're going to see a lot of developing markets trying to do 250 plus clients at much lower speeds, 10, 25 megabits. And that'll be very sustainable. And you'll be able to take advantage of high peak speeds because, as oversubscription is usually 20 or 30 to 1 in a lot of these cases. So, I think you can expect that you'd see those speeds, but you got to watch out for your peak hour, is what I would likely say. There were some other, so for example, if you're trying to do FCC requirements of proving that you're doing 100 megabits all the time, absolutely not. That's going to be way too much capacity for the access point if your sustained bandwidth needs to be 80% or 90% of the 100 megabits. So just watch out for your sustained guaranteed bandwidth number and divide through the capacity number pretty straight through, and that'll give you your answer. I want to set expectation accordingly there. Okay, so there was also some questions here on a similar question. Tyson, I think you sent this in as well. What's the impact on running on a smaller channel? Well, the good news is, from a scheduling perspective, the OFDMA capabilities, that really actually doesn't change whether it's 80 megahertz, 160 megahertz, or 40 megahertz. So we're still much more efficient. So we can still get a lot of clients on there, but the capacity that could be hit at 40 megahertz is 25% of what we could do at 160. So again, just watch your math on the sustained speeds that you want to get, and anything above that during non-peak, you're going to get the max speed that you're shaping that customer to, or that you're trying to deliver to, no problem. But just watch those sustained speeds for peak hours. But really, I do think you're going to be able to reduce channels and keep going up in client count, where we couldn't do that as easily with a traditional strict TDMA scheduler. So definitely, I think there's a bit more efficiency than we've had before in that scenario. Ashley, anything you want to pause me on, and or just keep on going on some of these questions?
I think I just want to remind everyone again, the Kahoot game will start at the end of this session for your chance to win the AX surprise gift. I will put the link and the PIN number again in the chat, but we won't start until after the session. So okay. If you are logged in, we will start afterwards. Okay, so you can sit tight, and we'll begin the quiz after this session. Thank you.
Great, thank you. So some more questions on spectrum and channel use. So this question was from Eric, and this was around, I think also up in Canada. This was also around, can we take blocks from the different bands, for example, and then block them together? So could I block together a Uni 1 band and a Uni 2 band channel, and similarly Uni 2, Uni 3, or even separate Uni 1 and Uni 3? And so there's some really unique capabilities in the A6, and some of them we didn't talk too much about, but I can spend a little bit more time going through now. So the answer is absolutely yes. We can go across adjacent bands, no problem. And the only challenge there is, of course, you have to go down to the lower power level of the lowest common denominator of the power levels. So the Uni 2 band, the DFS band, will dictate your power level when you do that. Now, we also are going to introduce in the current hardware that we'll be shipping with, it also can support dual channel mode. So for those of you that loved dual channel on our backhauls, our B series, we actually will be introducing dual channels, and that can be used for two different applications. It could be used for different SSIDs, perhaps, that you want to run different channels for different services. And that could be a 6 gig band channel and a 5 gig band channel for that matter. And we could do that to bond together channels, or we could do it also for running, let's say, 6 gig at shorter distances and 5 gig at longer distances of different customers. So there's some really cool dual channel capabilities and use cases that allow us to split up the band into different channels. So when we do that, you split into two 4x4s. So essentially we can take our 8x8 and split it into two 4x4s and put them onto two different channel sets, which is totally unique. Obviously, this is the first time that's been done in the market. So we're going to be learning kind of about the use cases and best ways to use that in kind of the coming months, I think. But really cool capabilities there for us to be able to kind of split up the spectrum, because we all know that you don't always find the adjacent channels you're looking for, especially in the 5 gigahertz. The 6 gigahertz should be fairly easy for us to get those 160 megahertz channels. Moving on to some of the connector discussions. Scott Miller had a question around our 10 gigabit fiber SFP plus is what we're supporting right now. So technically speaking, we are limiting it at the moment to 10 gig fiber. So the question was, could we use standard SFPs on those fiber ports? At the moment, the answer to that is no. We are working on a software roadmap to add that capability. I've verified that that's not a hardware limitation, but I just don't have a schedule for that at the moment. So initially, it's going to be 10 gig on those for interconnect, et cetera. But you can still connect 1 gig Ethernet copper to the base station and then interconnect using the 10 gig fibers without having to have a switch in the middle. So that wouldn't cost you anything additional on the switch, but you would have to run copper on that connection to feed that access point. So we can bring the 1 gig in on copper and then stay with the 10 gig on fiber. Eventually, we'll add some software features there to allow other types of SFPs, but I don't have a timeline for that at this exact moment. Next question was on production, and everybody knows that there's a huge supply chain challenge with chips out there right now, and are we going to be able to get to the production levels that we want in 2022? Well, I'd be crazy to tell you that it's not that there's not challenges, but we have been working on this for well over a year on supply chain and pre-ordering everything we could, knowing full well that we're still in the middle of this COVID chip issue, and the foundries, TSMC and others, that are kind of allocating chip production between the car manufacturers and others. So the good news is we are fairly BOM complete, bill of materials complete on hitting the volumes that we're expecting. So ideally, there will be minimal impact to this. We've done as best as we can and really put a lot of effort into investing in buying ahead on this technology so that there's plenty of chips for CPE, et cetera. The hardest part, though, is of course going to be just ramping up our production facilities. So it's going to be a little slow to start with. Obviously, getting all of that kitted and getting it through into the channel is going to be a slow process at the beginning of 2022. But I think that we've done a fairly good job. We're always going to be running into issues that are unexpected, but we have been pretty aggressive on our operational side and supply chain side to make sure we have what we need to start to fulfill the demand. But I fully expect that there will be some kind of shortages in the early days. So I do encourage you, if you are wanting to get on the earlier side, don't wait. It's going to be, there's going to be a long line in the first few months as we get production ramped up. So there were, let's see, just scanning down real quickly. Let's talk about FCC approval for the 6 gigahertz. So Ryan Bowman asked a question here about that. So the simple answer is it's currently slated, and by slated, I mean we're expecting it to be completed by around late Q2 or early summertime of next year. And what's really happening right now is we have all of the rules from the FCC that has all been approved and put on public record. What has not been finalized is the interoperability and the certification processes for the automatic frequency coordinator. So to back up a step, to operate in the 6 gigahertz, there's a couple things we have to do to get standard power outdoors. Standard power equals 36 dBm. The only way you can operate outdoors is with using the automatic frequency coordinator. Automatic frequency coordinator is a database. We are working with a few different providers right now to sort out who we want to use and the commercial terms to using the AFCs. The AFC talks to the FCC database, looks for legacy 6 gigahertz links, and decides what channels will not interfere based on your deployment location, based on the GPS information from your radio. So you will, when you install the device will call back to the database with GPS information, and you will tell it it is a 90-degree sector with this antenna gain and this power level, and it will say, okay, you are limited to this power on these channels, and you can now start to operate. And then it rechecks daily. So there are several prototype AFCs that are out there and completed. I won't get into them for non-disclosure reasons about which ones they are, but there are a few out there that they are starting to do testing with. At the moment, we are doing a ton of experimental licenses in the 6 gigahertz, partially to help explain to the FCC that we do not believe there will be any interference caused. A lot of the guys that are working on the AFCs are actually helping our customers with their proposals to the FCC for using experimental licenses so that they can run a prototype AFC coordination exercise in advance. So we're seeing a lot of manual and some automated processes for looking at the antenna pattern of the sector that's going to be used and determining whether or not there's any impact. And so far, we've actually had great success in getting these experimental licenses. So I'm quite optimistic that the band is going to be fairly open and relatively easy to use in the areas that WISPs typically are going to be operating in. So overall, I think there is quite a bit of work going on. I know there's a lot of leadership from our friends at WISPA, Richard Bernhard and others that are working on getting these AFCs certified and also lobbying on behalf of products like ours to make sure that we're well optimized for outdoor operation. So our plan, just to get that on record, is we're going to be done with the product and shipping well before this. So we have to come up with an FCC certification strategy that gets the product to market, but then gives us a software upgrade path to add the AFC and FCC certification. So we will start by certifying Uni 1, Uni 2, and Uni 3, so the main 5 gigahertz bands. And then we will pause on any other use of the band other than experimental use for 6 gigahertz. And as soon as we're able to get the FCC accepting certifications and interoperabilities with the AFC, we will then light up the software release that has that in it for the A6. And we are working as well on offering AFC support in some of our legacy products. Our legacy products, many of them support up to 6.4 gigahertz as well on the B5 series and the A5 series. So we want to make sure that where we can reasonably offer a software solution and AFC and certification solution. Obviously, there's a lot of cost involved as a supplier for us to recertify all of our products. So, that will take some time for us to get done. As you can imagine, trying to take 10 products back through FCC certification is not a fun endeavor. So we're going to probably focus on the new products first, and then pick and choose a few other products right after that we can get certified with the AFC bid. So hopefully that covers the most of the AFC related aspects. I'm sure there will be other questions about it. in an ideal world, we'd like to offer that AFC solution as part of the product. I can't guarantee that yet until we have commercials lined up with our customers, but I can say with confidence that this is not like the CBRS SaaS. If you were familiar with it, it will be significantly lower cost to operate that. It's a much lighter type solution, and we've gotten good confidence from our AFC partners there that it will be, we'll have less cost involved for that. Okay, so I'm going to run down and keep looking at questions here. Ashley, if there's anything you want to interject here, let me know.
Sure. I think let's have a little bit of fun here, guys. If you like the virtual open house so far, give me a reaction. There's a reaction button at the bottom of your control panel. Give me a thumbs up, a happy, a heart, or any other expression that you'd like to make, just so I know whether or not you are enjoying this session or not. All right, thank you. Oh, I'm seeing a lot of thumbs up here. Thank you.
Excellent. So let's take some nice easy questions here. So one question from Joshua Chan was around, so the access point supports 7 gigabits. And if you wanted to cut, and that's only in 90 degrees. So if you wanted to cover 360 degrees at the moment, you would put in 4 access points. And with that would take you up to 28 gigabits possible, of course, of capacity. So to do that, we would suggest, of course, running it in SRS mode. That software is going to be in the second release of software of the product, but that would allow you to operate on 2 channels instead of 4 channels. Really, there's not going to be 4 channels of 160 megahertz available to us, so we really would need to do that back-to-back channel reuse. But the great news is SRS, the spectrum reuse sharing mode, will allow us to do 2 channels on 4 radios. Now, obviously, this is only our first product. We have a lot of interest in people that are asking for something smaller in capacity for more like a micropop site where you don't need 28 gigabits and the cost of 4 access points. So obviously, this is something that we're working on. I think that you can imagine having an 8x8 radio, a single 8x8 radio supporting 360 degrees in 4 different directions. That would be very ideal. That we know that that's of strong interest. We're working towards something like that. That's all I can say about that right now, but that would certainly reduce the cost per site, so you don't have to have multiple base stations at the site. So we will be introducing additional access points next year. Just be patient with us as we start to flesh out the rest of the product line for you. But that'll help get to a lower cost point on the base station, but still have 200 plus clients. I mean, 200 clients in an Omni style configuration is way more than most people need for the distances that you can go with 6 gigahertz. So I think that'll be a really sweet product as well. But initially, we're working, of course, on the 90 degree. Let's see, any plans for 30 or 60 degree antennas or external antennas? I sort of just touched on that. So we will offer more of connectorized aspects. I do not think that we will offer any integrated 30s ourselves. I think that's a bit narrow for an 8x8 beamforming product. So I think as I like to call it, the great hornification or the move towards horn antennas was really necessary in the 802.11n and 802.11ac world. And you were going down to really small channels. But now that we're doing beamforming, which basically are these kind of 20 or 30 degree beamforms, the capacity on that radio is much higher, and we can also run without as much noise impact across wide channels. So I think there's going to be some rethinking of how people use wider antennas versus narrow antennas. It's a lot of people put tons of the horn antennas up with radios on tower sites right now, but that's quite an amorphous blob of antennas that you have to manage. So I think the hope is that the 90 degree gives you similar performance, but much higher gain than you would see with kind of the traditional horn antennas and narrow antennas, and higher client count, so that you're really taking advantage of one radio providing the performance of 7 or 8 radios separately. So that's really what I expect to see out of a 90 degree. That said, we want to support you when you do want to connect up narrower antennas, but that'll require probably a connectorization kind of solution for that. Okay, The one question was, will the client radio allow for installer EIRP control? And I will give you two answers to that. In the 5 gigahertz, yes. Of course, you will be able to not so much control EIRP. You control what antenna gain that we are allowed that we're twisting on to our C6 antenna. So, you tell us, did you put on a 25 or did you put on no antenna? And that adjusts your EIRP in that fashion. Now, in the 6 gigahertz, there will absolutely be no control of that as far as what the FCC tells us the EIRP level is. And you are expected to select the absolute correct antenna that you've installed. And the reason I say that is that AT&T and many others out there, this is a very enforceable solution with the AFC database. So this is not a situation where there's nobody else out there looking at what power levels you're using. This is a system where a lot of the license holders are going to be looking for bad actors. And there will be a database that says who those actors are. So I would caution you strongly against anything to do with anything but the EIRP limit that has been offered to you by the AFC at that point, and making sure that you've put the right antenna information in. So with that, I'll leave it at that. But this is a very different situation in the 6 gigahertz than the 5 gigahertz. So just be cautious out there, because we expect you to follow the FCC rules as it relates to the 6 gigahertz for sure. I will always encourage you to do that across the board, but the 6 gigahertz in particular, just, we don't want you guys getting fined for trying to do things that really the product's not intended to support. Let's see, a couple more questions. There definitely were more of the questions about spectrum back-to-back channel reuse. And now let's talk about backward compatibility. We got a few questions around the C5X. And is it backward compatible, the A6 backward compatible to the C5X? Absolutely, we have a transition plan and a support plan for C5X clients. So one of the cool things you can do is the C5X, we will introduce some new software that introduces multi-user MIMO support on the C5X. Why is that important? Well, the A6 is capable of supporting these OFDM clients with multi-user MIMO. So we can run 11AC multi-user MIMO on the A6 and transmit to 4 C5Xs simultaneously. So I now have an access point that can use the low-cost C5X and get high performance. The only caveat to this is only going to be in Wi-Fi interoperability mode. So we cannot support SRS with the old OFDM clients. There's just unfortunately far too much challenge in intermixing an old TDMA OFDM style scheduler in with a modern multi-user OFDMA based scheduling solution that is on the A6. So the TDMA scheduling, so to speak, is not compatible between them. So you're going to need to stay in Wi-Fi interoperability mode in order to take advantage of the enhanced performance. But if you're trying to transition, you start with changing out the access point, and you do not need to change out the clients until you feel like you want to. You're going to get more performance right out of the bag with the new A6 as on the access point, and you can start populating in and intermixing OFDM and OFDMA C6X clients. So very useful feature for that. You are not going to be required to take off the old clients at any point in time. But if you do want to move into SRS or channel reuse mode, you will need to then move the clients to OFDMA. Let's see. Other questions here. Let's see. The question was around if licenses were needed for the A6 and the C6X. And I'm going to interpret that to mean, do you mean licenses as it relates to the FCC and the 6 gigahertz? Obviously, the AFC and the 6 gigahertz is an unlicensed solution. So there is no protection for users. So once you get the go-ahead from the FCC to use the channel, it's not a license. It's really just an okay authorization for use on a particular set of channels. And your next door neighbor wireless ISP can use the same channels. So, it's really going to be somewhat first come, first serve, and nobody else is going to want to obviously hop in on your channels if you're already using them, but they're not going to be protected. So that's the one thing you just have to keep in mind. It's kind of like the GAA channels in CBRS. Let's see. Just making sure that there isn't anything that I also missed on the questions so far. We've got a lot of great questions that have come up so far.
Amy, why don't you take your time with that, and I'll do a little pitch here.
Great,
I
thank
just
you.
want to say thank you to Streakwave for helping us put together this virtual open house. They've been an awesome partner of ours and continuously support us. So just want to give a quick shout out there to Angela and Jamie, not Jamie Fink, but Jamie.
The other Jamie.
Just the other Jamie. For supporting us and consistently being such a great partner of ours. So you guys make sure, if you're gonna look for any Mimosa products, go to Streakwave. They have been in stock of our products for quite some time, and they'll continue to support us with also the new products that we'll be having available soon.
I did just want to touch on that real quick if you have a second. As people know, we try to stock as much as we can and have the full product portfolio. As part of that, as soon as we get the green light to go ahead and order some of the A6 and C6X product, we will be putting them on purchase order. We usually try to fly some in. And speaking of flying some in, Streakwave is proud to announce that we're going to have the B5Xs this week. So there's going to be B5Xs available in the US.
That's great news. And like I was mentioning, you can see we're getting pretty happy with the X series of products. So we're going to start going super long distances on those pretty soon too, with these 30 dBi antennas coming in Q1. So it's an exciting product line. We've just continued to receive great feedback on the X antennas, just so people know, the 30 dBi will have its own mount directly on the antenna as well, which I'm sure will be music to people's ears, so they don't have to have an additional mount for elevation adjustment. But really cool stuff coming down the line. I think we're going to have 5 or 6 radios that all take those same antennas by for first half of next year, which is pretty cool. Okay, thank you, Jamie. A couple more questions I'll try to hit here. There were some questions around testing, first of all. So my suggestion here is, please get your name over to Jamie and group. I can say with confidence we have a list of hundreds that are wanting to test this right now. So it doesn't mean it's a first come, first serve. We're going to really pick the best folks that can work with us. So please get your name over to us. I can't guarantee anybody to get into the slot on the testing on this, though. It's obviously there's a lot of interest that we're dealing with here. So there were a few more questions, double checking here. Oh, on capacity on the client. So I mentioned that it's a 1 gigabit Ethernet connection on the client, which means 2 gigabits total, but the max speed in one direction is 1 gigabit. So the question was, okay, am I going to be limited by that? So it'll meet all of the FCC requirements for gigabit speeds, the way that they do the measurements, absolutely. But if you do want more speed than that, we will have a expanded speed client coming out with a higher speed port in the early part of, let's say probably second quarter of next year. So just be patient. We will have higher performance clients. Obviously, they're going to be a little bit more expensive as people that really want, true multi-gigabit and symmetric applications. It's going to be a bit more expensive, but that'll also be things that we also want to have GPS in the product, so we can do point-to-point on those products as well. So hint, teaser on that. There'll be backhaul grade CPE coming into the portfolio, which will be great. So definitely we're trying to make sure we have the right cost points around the CPE, as you can imagine. We set the price point on the CPE, super aggressively. I think we put it at around, I think it was around 195 range or something like that. So at $195 for a 1.75 gigabit CPE, we've moved mountains to keep this really cost effective, and also to get the antennas to be super low cost. So just for those that hadn't heard the pricing on that when we did the announcement. So the question that popped right up about the pricing. So C6X list price $195, and the access point list price is $19.99. So obviously that's, you're going to see a bit lower street pricing than that, of course, in the market. but that's the starting price points on the products. I think I've covered most of the questions here. Temperature ratings was another one that just popped up. So it's it's the same temperature ratings that we've had on our A5 products. So I think it's -40 to +50 C is the rating. So nothing changing on our ranges as before. So if you haven't had any issues with our previous products and temperature, then you should be okay with that. So not too much different in those designs. It's fairly difficult to get much higher than that with the enterprise grade chips and outdoor chips that we're able to get in these types of products right now. So let me see. So let's take a last call on a few more questions. If there's anything else that you guys would like me to touch on, I'm absolutely happy to. We've made it through a lot of questions. A lot of them are duplicates, so if I didn't call out your name, I apologize, but we probably got 2 or 3 of the same questions for some of these, but hopefully we've answered most of these here. Ashley, anything else you want to add while we wait for some more questions in case?
Sure. I just want to thank everyone for your time in joining this virtual open house, because obviously there's a lot of virtual type of events, you know, for the past close to 2 years now, and everyone's getting, you know, fatigued with all these virtual sessions. So, you know, the turnout today has been amazing. Thank you so much for taking the time out of your day just to be with us. And we look forward to 2022 being more in person, so we can see you guys and shake hands and really meet you guys again in person. So there are a couple more questions coming in here as well. Jamie, if you want to.
Yeah, sure. So
then I think we should do a hard stop at about another 3 minutes, just so people have time to do the Kahoot quiz at the end of it.
Yeah, that's great. Yeah, so there was a question on compatibility, interoperability with other 802.11ax gear. Absolutely, that is the key benefit that we're bringing here. And also, you know, there's some really cool elements of 802.11ax OFDMA that we, you know, because it's an upstream scheduled OFDMA, we're starting to get our scheduling technology built right into the chip. So there is some huge advantage to that, because you know, we believe it's even possible to do you know, scheduling to standard off-the-shelf 802.11ax devices, not even just our own, which could be really cool. So I think that's a big benefit there, and also for transitioning other 802.11ac based gear in an area where you want to move stuff that is running in Wi-Fi interop mode, even if it's not Mimosa, onto our platform as a temporary or a transition, you can do that as well. So obviously those are the big benefits there. I think that the big thing that there's a question here around 11ax versus proprietary, and I think what you can see with the proprietary solutions, right, that are out there right now, you know, while I think it was possible to kind of copy and paste the chip implementations, if you took a 2x2, you know, traditional, you know, proprietary fixed wireless, you could put a bunch of them together with some interesting antenna technology, but it really wasn't acting like a massive MIMO beamform solution. You know, the products that are out there today that do 14x14, they're all set up in MIMO groups, and you have to manually configure those MIMO groups. You don't need to do that with 11ax. We do that all automatically. So we're capturing channel state information and calculating multi-user MIMO and beamforming all dynamically. You don't need to worry about that. It eliminates so much of the complexity of that proprietary type system. Secondly, obviously, OFDMA is an incredibly complicated beast, and it's a very difficult thing for an individual company whose only application is fixed wireless to develop OFDMA native technology. And we're seeing that in the competitors that are out there, nobody is yet to introduce a off-the-shelf proprietary OFDMA solution. So I can pretty safely say at this point that as we predicted years ago, 11ax was going to be that point in time at which we could outperform and obviously be much lower in COGS cost overall, because the market all went in the standard industry to OFDMA. And I think that that's a big advantage. We get to carry with us a lot of the advantages that come with the 6 gigahertz chips that are coming to market and OFDMA. So I think the proprietary solutions, I think they've been fantastic for the industry, but the 11AC stuff started to catch up. There were still advantages to some aspects of proprietary solutions, but there were smaller channel size. They typically didn't have any kind of OFDMA technology and lower speeds. So, now that we're hitting 60 bits per hertz and doing OFDMA, I really struggle to see how some of the proprietary solutions can keep up. It doesn't mean that it's not possible to maybe build something a bit more advanced, but the cost to do that may be incredibly high and the time to market may be incredibly long. So I think what you're starting to see is the rest of the industry, in order to keep up, is needing to try to stay with 11AX technology, because it's just that much more advanced now than previous generations of proprietary tech chips. So that's my personal take. Of course, I work at a company that is building standards-based tech, so that would be, for us, that's the biggest difference that you'll see. And we can also commit to starting to do hybrid applications. We have a lot of customers that want to do fixed wireless and Wi-Fi on the same access point. I can do that. And I might want a hotspot in a suburban area as well as a micropop. I can do that. And that's a big advantage. I think that that's something we didn't focus on as much with the 11AC technology. We're absolutely focusing on that in the new 11AX technology.
Thank you so much for joining us and taking that quiz. I hope you had a blast, and we look forward to doing some more of these sessions, hopefully in person versus virtual. But thank you for your time, and thank you, Streetwave, for hosting this for us.